thank you again for attending this session, and thank you, Mr. Chairman, for the introduction again. I'm going to try to compensate for the extra time if I took from the first one. To give you an idea of what the purpose of this study was, is to look at the selective laser melted technique, which is categorized as one of the additive manufacturing processes. And what we are going to do actually is concentrating on a special, very widely used high strength steel, which is Inconel 718, which you heard about that in the plenary sessions this morning as well. Briefly, I'm going to see how pre-straining might impact the properties, the mechanical strength in tension, in compression, the microstructure, and the surface hardness of this material, and compare that with a different technology, which is the forged components made of the same material. So the aim is to investigate improvement in structural integrity of pre-strained superalloy Inconel 718, and the objective is through fabrication of samples by this technique, and then extracting specimens, applying different levels of pre-strain on them, and then putting them into the tensile and compressive tests, and then see how the impact is. Then look at the microstructure and see what sort of changes we can see, and if we can relate those to the improvements that we will hopefully see following this sort of treatment. And for the as received and forged samples of the selective laser melted technique and the forged components. So this is a brief indication of the importance and significance and the width of the range of applications of Inconel 718 that you have already heard enough about that, and I don't need to stress any further. That's the justification of why we focused on this material. There is a composition of the material in the table, and then you can see the samples and the direction of the components that were selected for tensile testing and for compressive testing. And this is the tensile test sample, and the compressive test samples were bars, basically. If we start with the mechanical properties in the as received, you can see the SLM in compression and in tension, and also the forged in the tension and compression, both in the as received condition. And this table summarizes the values that we have. You can see that the forged materials, as we expect, is significantly higher strength compared to that. But we know the obvious advantages of the selective laser melted technique, and including the accuracy that we can get in the dimensioning, etc. And also the costs of the forging could be also another contributing factor to going for this sort of techniques for fabricating components of Inconel. So here you can see the pre-straining direction for both tension samples and the compressive samples, and different levels of pre-straining that we impose. So pre-straining for the tension is in that direction, whereas the loading will be in a transverse direction. But for the compression test, the pre-straining and the loading is in the same direction, obviously. To see what level of pre-strain is enough to cause to make an impact on the response, we need to see if we can exceed the yield strength of material or not. For the 5% for the forged one, we can see that we haven't passed the elastic limit, so we don't expect any impact of that. But for the rest of them, you can see that there is a significant plastic strain remaining in the components in both forged and the SLM ones, and the same story, and very significant plastic deformation when we apply a higher level of pre-strain, which in this case is 30% compared to 15% and 5%. So if we now look at the impact of that pre-straining level on compressive strength of specimens for both forged and SLM, for the SLM, we can see these responses. As you can see for the SLM and for the forged material, these are the impact of different levels of pre-straining. For 5% pre-strain, you can see almost there's no impact there as we expected. And for the others, there is some impact, and the level of strain that we apply up to 30%. In some cases, as you can see, depending on the level of pre-straining, the ductility of material is also changing to some extent. So if we look at try to make a quick comparison for the yield strengths of the two materials, you can see under the direction of the increase, and for the forged material, so it looks like similar trends. Doing the same thing, but this time focusing on the tensile strengths, we can see the variation in tensile strengths for the forged material with different levels of pre-straining, and for the SLM with different levels. And in this case, we can also look at the ultimate strengths as well that can be compared. Now, see if there is an impact on the microstructure. Unfortunately, we didn't have access to SEM, so we just focus on the optical microscopy in this study. And you can see in this diagram how they compare for the 5%, 15%, and 30%. There is generally an increase compared to the as received for the Inconel material. And the size, it was a bit challenging to measure an average size, but we had to take a sample reference cell and then find the size and take the average for this 4 different structures which are reflected in this diagram. Same study for the Inconel forged one. You see the trend is different. So the structure, the average grain size has significantly decreased from as received as we increase the level of pre-straining. So it's inconsistent with what we observe in the SLM. If we look at the surface hardness, we can see generally forged surface hardness is higher, but not very significantly. And these are the records of the Brinell hardness numbers that you can see. There is not significant impact from the pre-straining on the level of the hardness that we get for both the SLMs and for the forged ones. So this is an observation that we can put into a number of conclusions. There are some cases where the changes or the impact is very significant, and there are cases that the impact is not so significant. For example, I can stress on this one, significant improvement of up to 80% in compression strength when SLM samples were subjected to 30% pre-straining was achieved, which is very significant, very important. It is very promising that pre-straining could be used as a post-fabrication process to significantly improve the mechanical strength of Inconel, where we use the SLM technique to make them. We also can see improvement in tensile strength for forged samples, and the ultimate strength. For the ultimate strength is not that different, but for the yield strength, it is much better, as you can see. In tensile strength is 30% compared to 12%. So this is the frame for a further study, which is what we can do by looking at providing a database of test data for different levels of pre-straining. We can try to simulate this process and then put them in sort of introducing the extensive data source to a machine learning or AI system to try to predict the impact for if we have sufficient size of the database or test data. But of course, providing a significant amount of test data means cost at the same time. So that's all for me. Thank you very much.